Welcome to EDU World Space.
All right, so here we have a vector. You can see all the components, and we are going to find the arc length. And then we're going to be able to basically get t in terms of the arc length. So that's pretty cool. So basically, let's take a look at arc length then. We're going to use S for arc length. And we are going to integrate starting at 1 because we are increasing from t equals 1. So we're going to go 1 till t. So we have a generic equation for whatever t we end up with. And the arc length formula, we're looking at taking our derivatives of each of our components and squaring this, taking the square root of the sum of the squares. So this is just the general formula. It's getting a little sideways. And that's a z here at the bottom. Let's fix that so we can see it. Okay, so z prime of t squared. Okay, so we take all the components, square it, add them together, square root, and that will give us our arc length. So let's put in all the right parts. We're going to do the derivative of our x component. So we get derivative of 5 minus t is minus 1. So we get minus 1 squared. Now we take the derivative of 4t minus 3, so that's 4. And then we square it, and finally derivative of 3t is 3. Okay, so we get 16 plus 9 plus 1, so we get square root of 26. And we just need to finish the integration. I need a dt there. Okay, so s then is going to be square root of 26, antiderivative will give us times t. Plug in our limits, and we get root 26t minus root 26. Or if we factor out the root 26, then we get times t minus 1. Okay, so there we have s as a function of t, but we want to get t as a function of s. So we're going to then, remember all this equals s. So I'm going to take this and rearrange it. So I can do that by dividing both sides by root 26 and then adding 1. So t then is s over square root of 26 plus 1. Now I have time in terms of movement along my curve. So that's super cool. Nice. So now we're going to rewrite our vector r of t in terms of r of s. So that's really neat. We're going to substitute in. I'm going to kind of need room, so I'm going to lift this a little bit higher just so I can use the root below. Okay, so there's t as a function of s. And now I'll clear the bottom so we can finish up the first part. So let's clear this off. Okay, so let's get our change of variable. So now it's r of s. So every t gets replaced by s over root 26 plus 1. So I'm going to get 5 minus quantity, s over root 26 plus 1. That's all in the I hat. I'll clean it up in a second. Now we have 4 times the t, so we do have a bit of cleanup work to do as I substitute in for t. And that's j hat. And then finally 3 times t here. K hat. All right, so that's kind of messy. Let's kind of get our final answer. We'll combine what we can. It looks like 5 minus 1 is 4, so I get 4 minus 5 over root 26. There's my I hat. The next one I can distribute, so I will get, looks like, I will get 20 over square root of 26. Oh, that's not 20, it's 4s. Ah, my s looked like a 5. I start thinking of them as 5, so I have to rewrite this. This is with an s. Okay, so there's my s. Make sure it looks like an s, not a 5. That's an s, and that's an s. Okay, so I actually get, let's clear this up. I accidentally erased some stuff. Okay, so that is a s. Okay, the next one, it's 4s. 4s over square root of 26. Then I have plus 4 minus 3, so plus 1. That's j hat. And then let's see, I can distribute the 3, so I'll get 3s over root 26 and then plus 3. And I think that's it. That is now my vector with a change of variable to length along the curve. So very cool. All right, so that was good. The last thing we have to do is simply plug in 4 for our S, which is our length along the curve. So I need to make more room. So let's see if I get rid of the parenthesis, I might be able to fit it just below. So let's try to do that. Okay, so right below at the bottom, I'm going to go ahead and find our last step is find our vector at 4 units along our arc length. So I'm just going to substitute every s with a 4. And then I will be done. So then this will be 16 over root 26 plus 1, parenthesis, j hat. And let's see if I can move this out of the way. Okay, so for some reason my board is having troubles. Okay, and then plus, I'm plugging in a 4, so 12 over square root of 26 plus 3, and I think I've got it now. So that then is our vector. Well, we've moved 4 units along 4 units along the arc length. Okay, hopefully that helped. Have an amazing day.